just yesterday, I decided to look in the news and see how many recent news articles as of this week are talking about the reproducibility crisis in science. And there were so many, I couldn't even paste enough. I mean, I could have made them really small, but they're everywhere. So most of you may not even have been aware of that, but in science, this is a big, big deal. We're having issues in being able to reproduce our results in many different fields, in economics, in psychology, in neuroscience, in the clinical world. This is a big deal for science. And so you need to be aware of these kinds of things just to know not that science is broken, but there are some issues. Nature did this big study where they asked a bunch of scientists themselves, is this a crisis? And more than 50% said, yes, this is not just something to be aware of. This is a crisis for science. If we can't even reproduce what we're collecting, science seems, what's the foundation of science? So one of the more famous papers around this reproducibility crisis issue was a paper that was published in Science not too long ago, estimating the reproducibility of the psychological sciences. And they went through, this is a very expensive endeavor. They went through 100 different studies in top journals in the field of psychology and tried to replicate them. How many do you think they were able to replicate? Just think in your head. You can just think for a second. See if you're right. 39 out of 100. These are results in top psychology journals. These are results that were shown to be statistically significant and there's, by the way, there's lots of different ways of measuring how reproducible a particular study is. It's not just by looking at whether you get the same p-value. There's effect sizes, there's power, there's all these different things that you can look at. You can also look just at whether it's conceivable that the results are similar. But that's a big deal. That's actually a really big deal. 39 out of 100 of these well-known studies could not be replicated, and yet they're landing in offices for people. When someone goes to the clinic and they get advice, it's not just the blanket examples and the couples and the beer study that I'm talking about. A lot of these kinds of studies, especially in the clinical world and in the economic world, our economics depend on it. If we can't even replicate it, that becomes scary. So they looked at this. They found that if you looked at the studies, the effect size of the original papers and the effect size results after they attempted this author set, attempted to replicate or reproduce these results, you find that if it was on if everything was going well, it would be sitting on the diagonal. But it's actually so bad that this is 0. This would be at a 0 effect size for the replication effect size, and these are below. So that means it's in the opposite direction. It's kind of like the Reinhold example. It's not just that there's a less of an effect size, it's the opposite. That's even worse than just being somewhat off. In industry, CEOs and leaders in the field in biotech and pharma are coming out and saying, well, we've known this for a long time. We already know that probably 50% of the studies published in top-tier academic journals can't be repeated. We know it. We can't repeat it in our labs. This should be unnerving because we depend on science to fly in those planes, to get that antibiotic that you need when you get sick and have an infection, when you land in the emergency room. This is a big deal. Cancer research. They're doing efforts in the field of cancer research, looking at how well they can reproduce some of the key results. This is a problem. The Federal Reserve had, there was a paper not too long ago by 2 individuals that found that they couldn't really verify a lot of the results that were coming out of the major institutions and organizations that were driving economic theory. So the then editor of the American Economic Review, Ben Bernanke, said, okay, enough is enough. We've got to change some standards in these journals and the way we publish. So the good news is there are efforts to try to fix this and ameliorate it. And I think we can, and Carl's going to talk more about that. There was a paper that basically showed, so they did a similar thing in economics. They went through and they tried to do some replication in these top journals. These aren't just like random journals. We'll talk about next time. There are random journals out there that aren't high quality. If you look at there, 33% they were able to, so the key was that 22 out of the 67 papers were, without contacting the authors, they could reproduce. And if you had to contact the authors to get data and results, then it was around 49%. So they're changing a lot of the journals are now requiring that you create these environments where you can reproduce your results. So these are good things. Now this has become such a big deal that the fields themselves are comparing themselves to each other. So the economists are saying, okay, we're bad, yeah, but we're not as bad as psychology. So they compared themselves to psychology here for all these factors. And it's funny, if you look at the paper throughout, they're like, well, we were 19% better here, we were 17% better there. In fact, we're just way better as a field. This is a competition that I wish we weren't having, but we are. So we're going through this stage right now in science, just like in the real world. So this class is about calling BS in our world overall. But in science even, in this rarefied world where we think it's this bastion of truth, we can't even reproduce some of these results. So there are some other classes that are actually in the Pacific Northwest. This is from a professor at the University of Oregon. He's an experimental psychologist. He's looking at, psychology is mess, the testing is mess, causal inference is mess. Everything is just terrible. So, is science really just a house of cards? Is it ready to fall? Are you going to fall out of that airplane? No. I think we can come up with some solutions, and like I said, Carl is going to go over some things. We don't have time to do this discussion, but I just want you to think in your head. How can this happen? What is causing that? So let me just at least pause for 5 seconds without me talking so you can think about that. What is driving this reproducibility crisis? What could be causing? There's a lot of things, but just think in your head, what could be causing this reproducibility crisis?